Hi there. So this is a demo video on the project chat app with the behavioral biometrics. So let me just show you about the project. So in this, we have a basic chat app in which we are using WebSockets and it's running on FastAPI. And on top of that, we are using behavioral biometrics. So basically, we are using LSTM models, and these models are really good in uh, using temporal data, and they store the previous state information also. So basically, these are long short-term memory models. So it stores the long-term informations and also the short-term information. So that's why they are very good to understand the features based on uh, in our current use case is keystrokes and the mouse events. So what we are using is, let me just show you. So we are collecting users data. So let's say I'm in the user 2. If I log in as user 2, so in this, we are collecting the keystrokes and the mouse events of that particular user. And when we have the enough data, we train the model for particular user and then use that model to determine if the user which is typing is the legitimate or not. So like if I start typing in here, like hey there everybody, how are you doing? Doing? So as you can see, the confidence goes down and we have a strike system of 3. So whenever if the confidence is down and it crosses the third limit, we log out the user. So what we are doing is, let me just show you what we are doing. So we have a service. In this, basically we are checking, like let's say we have a mouse model and we have a keystroke model. So and we are collecting both the data, and based on that, we are generating the scores. So as you can see, this is the score 0.0003, and this is the mouse score. So both are very low, which means this is not the correct user. So I am user 1, but I logged into the user 2 with their ID password. So our behavior collector will collect the data, our model will predict the outputs, and based on that output, we are checking like, okay, if this user is to be allowed or not. So we just log out user if it's not legitimate. So if I just again go to the user 2, we also have a voice feature. So for voice feature, we're using ICAPA TDNN model in which we are basically, let me just show you. So we have the voice embedding. So if I speak something, hey, how are you? How are you doing? And yeah, so what it will do, it will basically process my audio. It creates the embedding and then checks based on the voice data, like if that voice matches with the correct user or not. So it is taking some time. Yeah. Okay. So we have the voice pipeline. We have the voice score, which is 0.68. Okay. It's collecting the data, so that's why. So we have two, three things in this voice message. So like if you are a new user, so we need to collect some data, right? And when we have the enough data, we create a centered value of those embeddings, and based on that embedding, we are checking the similarity of that particular voice uh, to the user's centered value. So if I go to the neon, I'll just show you. These are the speaker embeddings. Uh, yeah. So in the speaker embeddings, we're storing all the embeddings which we are generating on the model. And we have a user voice profile. So these are the voice profile we generate. In this voice profile, we have a central value. So whenever new voice comes, we perform the speaker, like we generate the speaker embeddings. We perform the similarity matrix, like cosine similarities on the centroid value and see if it matches or not. If it is matches, it means it's the correct user. Otherwise, it is a different user. And in this, we also have a separate feature which is group chat. In the group chat, uh, like we have multiple users, and what we have did is we are collecting the information, and on that, on top of it, we have trained idea system. So idea system is basically we have collected uh, these features. Yeah, these features. We have a message rate, fast score, the reputation score, and link ratio and the failed login attempts. And based on these features, we have trained random forest models and the isolation forest models. Random forest model generally gives us the information if this matches with the user patterns which the generally users uh, type, right? So we'll check like what's the message rate, what's the bus score, what's the repetition score, is it varying or not? Based on that, random forest will give us probability score. And then we have the isolation forest, which is another model and which tries to find the anomaly. So we have trained that model on the label zero data. So basically, we have trained the model on the normal data which we have. And based on that, when we pass the new features, it will check like how deviate is it from the current data. So if it is too deviated, it means it's an anomaly, it's an attack. And we got two different scores, and then we fuse those scores with different weights, and when we have the final combined score, we check if it is below 65, it means it's okay. Otherwise, if it is too high, we log out that user. For group chat, we generally block that user for a specific time. So like we block the user for 5 minutes. So for 5 minutes, he won't be able to send any messages in the group. So if I type same messages in here, so it's currently loading the models in the background. So that's why it's yeah, it has loaded the model RF plus isolation models. So you can see we have this, and if I type again, we have a 10-second window, and in that 10-second window, it will check, collect the features, check if it matches with it or not, and if the score is too high, we'll block the user. So we have detected that it's in a spam or attack pattern, and we have blocked the user for 300 seconds. So, and this is also persistent. So we are storing these informations in the DB. So if that user logs out and logs in again, he won't be able to message anyone until that time. So if I log in again, loading the model, and after that, we also have one more thing. We have an adaptive trainer. So basically, what we're doing is we are collecting the information, and we have a separate uh, worker which is running on top of this, which is monitoring the keystroke data. So let's say we have trained a model, and now we are collecting more data. So when we have the enough data, we train another model of that particular for that particular user, and we like move the previous model to the archives, and we use the new model. So we have developed that also this. So we have a threshold value. So like if on the first login it will be 1,000 keystrokes, other will be 3,000. So if the model is already trained, we'll use 3,000 rows, and we automatically train the new model, update the previous models, and move the previous models to the archives so that we can track how the models have been. So that's all for Thank you.